So what we're going to have a look at is how transformers work within the national grid. If you have not looked at a national grid video already, or if you've forgotten all about it, my video is on YouTube already at available. But just as a quick recap, so in terms of electricity generation in the United Kingdom, this happens at a power station. The electricity is generated using generators in a power station. It is then stepped up, so the voltage is then stepped up across the cables, and then to get to the home, it is then stepped down for safety reasons and passed on to the domestic user. In terms of the concept of a step-up transformer, as we discussed in the national grid, power is equal to current times by voltage. Therefore, the voltage is increased and the current is decreased because of the conservation of energy. The power that is put in is the same as the power is put out. Because the voltage is increased and the current decreases because this value stays the same, there is less heat loss and therefore it's a more efficient process. The national grid does not include the power station and it does not include the domestic user. It is the step-up transformers, the cables and the step-down transformers. And that is a brief recap. So a step-up transformer has got more turns on the secondary coil, okay, less turns on the primary. For a step-down transformer, this would be reversed, so you would have more on the primary and less on the secondary. So the step-down transformer is the opposite. Okay, and what it is it's two C cores, okay, that are made out of a laminated iron core. Okay, iron because it's the easiest to magnetise. The current isn't intentionally going to flow down here, it's the magnetism that's going to cause the transformer to work and operate. Laminations are there, laminations means layered, okay, so if you think about laminating a certificate, okay, then that is putting a layer on top of it. Those are there to stop little currents from forming and heat loss occurring. But you'll look at that at A-level. The A-level video about transformers is also available on YouTube. You need to be able to explain how a transformer works. It's pretty straightforward. If you don't understand it, there's a trick to writing down an answer with this. Okay, step one, alternating current is passed through the primary coil. Step two, this induces an alternating magnetic field in the iron core. Step three, because that magnetic field is moving in and out of the secondary core, this induces a potential difference across the ends of the secondary coil. Step four, alternating current flows in the secondary coil as part of a complete circuit. So let's pick this apart. The current is moving backwards and forwards in this in this coil here. Because of the generator effect, because you've got current moving, then that's going to alternate the magnetic field and the electrons are going to start to spin in here and that's going to cause the magnetic field to start moving backwards and forwards. Like a magnet being shoved in and out of a coil, because the field is moving in and out of this coil, that is going to cause regions of positive and negative on the wire, and that's going to induce alternating potential difference in this secondary coil. And if it's part of a complete circuit, then alternating current flows in the secondary part of the transformer. If you don't get it and you want a way to remember it, write down bullet points 1 to 4, write down the word alternating at the start of every sentence, and it goes current, magnetic field, potential difference, current. Because power in is equal to power out, if we have got 3 of these values, we can figure out a missing value. So power is equal to current times by voltage. So the current in the primary times by the voltage in the primary will be the same as the current in the secondary times by the voltage in the secondary. This is an approximation, okay, because this assumes that there's 100% efficiency, so that it assumes there's no heat loss. We know that isn't true, however, it's really useful in terms of an equation. Thank you very much.